So in week 7.1, we discuss about the constructor of the AVL tree. So there are three questions here. The first one is talk about the how to insert an element in an AVL tree, and calculate each balance degree for each node, and perform the related details. Follow the questions. And the second question is to delete the nodes for the AVL tree. And the third one is to list an array so that we can insert a node without any rotating. So move to the question one. The question one solution here is there. So let's check the steps. The step 1 and step 2 just insert the elements without any rotating. The step 3 is the step 3 stated here, and it needs to rotate because the balance degree here, the degree 20 is unbalanced, is unstable. So it needs turn right because it is a left type. So this is the final stage here. And step 4, we insert a new element 7, and it is stable. And step 5, we insert another element 5. So 5 here, we can see that the 3 nodes is unstable because 3's degree balance is 2. So we need to rotate this tree. We can find it is right-left type because it is right and it is left. So we need to turn right first, and then turn left. So the final state is here. And move to step 6. Step 6 is add a new element 8. So the 8 here cause the node 5 unstable. So we need to rotate it either because the 5 here is left right type. Oh no, not the 5 node, sorry, the 9 node, because the 5 nodes balance degree is -1. So it is stable, but the 9 node is unstable, so we rotated it. And rotated this node, we can see it is left here, right here. So we need turn left and then turn right. Turn left here and turn right here. So the final state is here. And step 7, we add 25, and it is stable. And here is the balance degree. And step 8, we insert 30, and the node 20 is unstable because the 20th node's balance degree is -2. So we need to rotate this node with because it is right. So we need to turn left. So here we turn left here. And the step 9, we insert 15. 15 here cause the nodes 9 unstable. We can see the 9's balance degree is -2. So we look at this rotated type. We can see here is the right and then left. So we rotate it first right and the left. So we get a tree here. And then we insert, we insert which number? Oh, we insert 6. Insert 6, and it is stable here, and the balance degree here, and and the final step, we insert 17. The 17 here, it is also stable, and here is the final tree, and here is the balance degree. And this is problem 2. The problem 2 discuss about the delegate. So we delegate which number first? We delegate 20. So 20 is here, and we delegate it because it has 2 nodes here, and the question asks us to replace it with the largest element smaller than the key of the delegate nodes. So we just find the largest node smaller than 20. So we find this and move this to the node, and then we get this tree. And then we delegate 15 is here, so we just delegate it, and we can see here it is unstable, so we just rotated it. It is right type, so we turn left. And here the third we delegate 8, and 8 is here, so we remove it, get a tree like this. But we can see 7 is unstable because no, now 7 is unstable. Let's we check. Oh, it's 7 unstable, sorry. It's 7 nodes as unstable, so we rotated it because the left tree has 2 nodes, so we turn right, so we get a tree like this. Sorry. So we get a tree like this. So the step 4 we delete 25. So 25 is here, and we deleted it and get this one, and here is this, and it is stable because there is no balance degree 2 here. So move to the next step, the step 5. Step 5 we remove 30 here, so we remove it, and now it is unstable because the 9 nodes is 2. The balance degree is 2, so we rotated it because it is left right type, so we got a tree like this. And step 6 we remove 9, so 9 here, and we got the the 9 here, and we deleted it, and now we get the smallest nodes, and we got the largest node smaller than this one, so we got this and switch this to this position, and we got this tree. So final we delete the next 17, 5, 6, 3, 7, and it is all stable here, just like this, and final empty. It is new tree here. And third question list order. So we insert these elements. We don't need any rotating, so we insert this sequence, and it is no need for rotating. So that's the final of this week. So that's all. Thank you.